My name is Darrian Hale. I'm a software engineer and a network engineer. I'm going to talk a little bit about vector packet processing. I'm not sure if anybody has heard of this, but this is typically a high volume packet processing framework. So where do we need this? This usually comes into play where we have a really large scale network. So you've won a great contract. You've built a giant network, thousands of APs, hundreds of switches. You spent millions of dollars on this, this infrastructure. You've had one large event and things didn't go quite as planned. Maybe there were some hiccups, authentication problems, what have you. Well, where could this problem lie? Well, it could be in the service delivery network, but let's assume that you've done the correct thing. You've done your pre and post installation site surveys. Maybe you even have a sensor network installed. You're ingesting telemetry from your infrastructure to make sure that it is always in a good state. It's delivering the service that you expect. So I'm going to focus on the routing side of things. This is where VPP comes in. Is a traditional router sufficient? Well, it would be if all we wanted to do is just push packets out to the internet. That's not all we want to do. We want to provide guest access behind a captive portal. We want to provide tiered services for the tenants or vendors at that site. Maybe we want to work with carriers to provide cellular offload. You know, when that large group of people come and the cellular network starts to decay in its performance, those devices tend to shift over to the wireless network. So what we really need is either a stack of equipment or an application services router. The problem with these two things is they typically don't scale well. If you take the stack of equipment, you have many things that could be the source of your problem. If you're trying to achieve high availability, you have to set that up for every one of these different pieces. And then the application services routers typically have their own inherent scale limits because they're doing so many things. So we're going to take on the daunting task of building our own ASR. So how do we do this? Well, we can leverage high core count servers. You can go and buy a 256 core 1U server from HP or Dell. We can leverage open source software. You like Linux, you like FreeBSD, all the other open source things that we're going to need, DHCP, DNS, web services, database, etc. You'll pick your favorite language to go and build the glue between those different pieces. You're going to need to develop automation to create the configuration for the packet processing and the firewall and your DHCP configuration and your web configuration, etc. But what about the processing itself, the packet processing itself? Well, we could do this in the kernel. This would be our traditional one packet in, one packet out. We have a queue of packets, we throw them into the line, and we do the processing we need, and then they pass through the infrastructure. The problem here is this doesn't leverage our high core count server the way that we really need. It also, when our configuration gets a little bit more complex, it doesn't behave the way that we want. So let's introduce VPP. This runs in user land. We can leverage our high core count servers. So why VPP? Well, it's fast. The reason it's fast is because we're processing packets in buckets instead of one at a time. We identify those things that have common rule sets, we place those into buckets, and we pass them through the chain. It's also configured a lot like the network appliances that you are used to. You log into your switch and you run show run, you run interface this, interface that. Well, VPP operates in much the same way. You can connect to it via a socket and you have a CLI and you can run commands that you would be familiar with. VPP, the folks that have developed this have clocked on Mellanox infrastructure running over 25 million packets per second, which is more than enough to handle even the largest venues in the world. There's some great resources. The FDIO folks have a progressive tutorial which kind of steps you through configuration. The folks at IP Next Generation have written a lot of great articles on VPP. The configuration that is on here is an example of what you would do in VPP to configure a system as your home router. So we're talking about one organizational unit, you at your house running NAT and DHCP. Well, this doesn't even include DHCP. This is just the VPP configuration. So you can imagine what it's going to take in order to configure that to deliver the services for your large-scale venue. But it is possible. You just have to find the perseverance to go and make it happen. In addition to routing the packets, we need to combine that with other services. The way that you do that in VPP is you can use the Linux control plane plugin. This ties in the operating system with the VPP instance. You could also use host interfaces, which is a simpler bridge mechanism between the two. This quote on here is interesting in the Linux control plane plugin documentation. I think it really describes well what VPP does, which is VPP provides a software-based ASIC for your forwarding, which is really slick when you think about it. You let your operating system do the things that it's good at, and then you take VPP and you let it do what it's good at. VPP has a great plugin mechanism. You can write your own, but there are many that exist. NAT, V4 and V6, WireGuard, many others. You can take a look at this URL to see what's out there. If there is some requirement that you have that it doesn't quite cover, well, you can write your own or contract someone to write that for you. So what does it all look like? Well, we have a simple diagram here that shows our internet access connected to our high core count server, or maybe it's a set of servers, connected to our service delivery network, all of our switches and access points. And when we blow that up, it looks something like this. Our physical appliance has network ports connected to it. Those network ports are taken away from the operating system and given to the instance of VPP. I highly recommend that you have at least one additional interface connected to your hardware that you do not give to VPP, so you always have an out-of-band connection into the operating system. So VPP handles our routing and NAT and any other plugins that we might have. And then on the operating system side, we're running all the rest of the services, DHCP, DNS, etc. And you connect the two together with the Linux control plane plugin through TAP interfaces or through the host interfaces that you've configured on the VPP side. My company has built its product on FreeBSD. So when we first started looking at this project, we're like, okay, well, we're going to do Linux because this is all that we can do with VPP. And we found out that there's some folks that were also interested in VPP on FreeBSD. So we've contracted the FreeBSD Foundation to port VPP to FreeBSD. There's been some great work so far. The folks at IP Next Generation have already started to write articles on this, and there's already been some work that has been merged back into the master branch for VPP on FreeBSD. So this will be available for everybody. It's awesome. As a software engineer, I want to build tools that I would use as a network engineer. This is like my goal. So that's what I am working on right now. I am working on developing the tool that will make deployment of VPP easier. It'll configure all the instances you may need. It'll take care of all of the stuff on the operating system side, and it'll put them all together. So that's all I've got. If you want to see what we've done so far, you can check us out at rgns.com/WLPC, and thank you.